Okay. Now, introducing the topic is a little bit fun, but not as fun as actually doing the experiment. So, the first thing we're going to do is we're going to celebrate a brand new unit by doing something ridiculously stupid. So the first thing I'm going to do is I'm going to go over here and I'm going to pull out a plate. Now, here are my plates. I know it's shocking. Bright colored plates, bright colored person. Okay, so I go in here and I have peeps. I personally don't care for peeps. I think peeps are kind of gross. But other people like peeps. I'm going to put, let's call him Herbert. No, because I have Herbert the tree. That's just mean. Let's go with Samson. There's Samson. Whoa. There's Samson, who does not want to go in the microwave. There's Samson. And then let's go with Martin. So Samson and Martin. And maybe I should try one because they can't be that bad. I remember them tasting like garbage, but we'll see. Sugary, strange texture. And it's kind of gross. Okay, so what we're gonna do, I'm gonna take these peeps, I'm gonna throw them in this microwave for 1 minute. The reason why we're doing this is because we are celebrating doing science at home, and we're just gonna have to do it. We're gonna make it work. And I don't have a microwave in my classroom, so this is something I couldn't do there, and I'm trying to do things I can't do in the classroom. I'm gonna go ahead and put it on for 1 minute. I'm gonna bring you over so you can watch it. So you're going away from the candle / water bottle setup. So just so you could prove, okay, there they are. There's Martin and Samson. There he is. Then there's the time. Now all you have to do is press play. Ready? Start. There they are. This is so amazing. What are they gonna do? Oh my goodness, they're going to blow up. Ah, that's so great. Look at them. They're expanding. Now, the basic science behind this is that they're marshmallows, and what they do is when you heat them up, they kind of puff out. Now, with all the molecules in there, because there are molecules in there, because everything, and atoms, of course, and they're vibrating, and they're causing heat, and that heat is causing them to expand because of the moisture inside. Oh, we got 25 more seconds. Let's see if they can take it. Let's see how big we can make them. Gosh, this is disgusting. Keep going. And all that inside there is all of that moisture that is wet, that is turning into a type of steam. It's adding, it's just puffing up just kind of like bread. Gosh, the Samson's ginormous. All right, it's actually starting to smell like it's burning, so I probably, well, luckily for me, it stopped. Now, if we look in here, I did. It's boiling and it started to burn. And if I touch it, yeah, it's pretty warm. So I should probably get one of these nice, don't burn your hand, pick up things type of thing. And look what happened. Now, they were so happy. They were so amazing. And now they're burnt. And now they're crusty. And when I touch them, they're liquid. Or they're almost liquid. The stuff that's inside of them is liquid. And outside is like a little film and skin. Now, if you would like to do this experiment, do not put it on for a minute, because as you can see right there, it started to burn, which is so gross and it smells so bad. All right, so that was the celebration. Congratulations for our celebration. So, welcome to chemistry. All right. What I'm going to do is I have this stuff. This is the stuff that I need for our experiments for the week. Now, I got all this at Smith's today, going out of quarantine, but only for a short period of time. I will try to keep everything like that down to a minimum. Over here is where we're actually holding the experiment. There's my ceiling fan, and there is the list of the first 4 elements on the periodic table. So, supplies, area, supplies, let's see if I can make your car sick, area. Okay, so let me go ahead and set up, and we're gonna go from there. What do you think, Yoda? Thank you. Okay, so here we are. I need to stop clapping too. I heard what that sounds like on the video, and it's not pleasant. First off, it still smells like burnt marshmallow, but luckily the door is open, so hopefully that'll get that smell out of here eventually. We're going to use this ceiling fan, and we're going to use this data, because data is information, numbers, lovely, lovely, lovely data. We're going to take this stuff here, and we're going to make ourselves some atoms. Because atoms make up elements, and elements make up molecules. Molecules make up macromolecules, and so on, based on your project you should have done yesterday. But we'll see. The reason why I have my hat on is because my cleaning lady has cleaned this fan regularly, but since I'm not the one that did it, I'm going to go ahead and put my hat on, keep my hair back, so I can take care of the projects. If you look at the data, if you look at our chart, the first element on the periodic table is hydrogen, which makes it 1. The reason why that number is so important is because H is the abbreviation, hydrogen is the actual name of the element. It has 1 proton, 1 electron, and hydrogen's special. All right, so let's go ahead and lay that out right now. Hydrogen is a very, very, very special thing. Alexa, stop. I have no idea why she thought I said her name. So let's try this again. H, hydrogen, 1 proton, 1 electron, but like I said, hydrogen's special. It has no neutrons. So that's the only one you got to worry about. You got to remember that one. We can't help it. You just got to memorize that one. It's an easy one. We'll go from there. We'll talk about mass tomorrow. Okay? Today I only have a 10-minute video. Yesterday I went over. I'm going to try not to go over today. We'll see what happens, especially with the celebration of the marshmallows in the microwave. Probably going to run over again. So, 2 is helium, abbreviation HE. Right? It has 2 protons. Whoa. 2 electrons. And 2 neutrons. Again, we'll go over the mass tomorrow. If you look here, very simple. Helium, 222. And it's the second element. And we're going to build that one too. Down here to 3. This is where it starts to get a little bit creepy. A little bit different. Not a lot different, so don't worry about it. 3, lithium. Li is the abbreviation. There are 3 electrons. There are 3 protons. Sorry, I switched it, but it's the same anyways, doesn't matter. But for some odd reason, neutrons, you got 4, which messes with the mass. So, well, again, tomorrow. 4. If you look down here in the last one, beryllium. I'm not doing very well with this not touching the face thing, but I'm by myself, and I've washed my hands multiple times today, so we're going to be all right. 4, beryllium. Abbreviation, Be. 4 protons. 4 electrons. And for some odd reason, 5 neutrons. Now, I'm sure better teachers in the world, teachers that do not teach my particular type of programming, probably can tell you the exact reasoning on why. I ain't worried about reasoning on why, and I actually use the ain't word too, so now I'm really slumming it out. So, as you can see, here is the masses. I kind of put it off the paper so you wouldn't be able to see it well, because I didn't want you to focus on it. So, here you go. And the only way to get you to see this is to be able to put that Post-it note, that giant Post-it note in the back, so we'll see if that works. All right, here's our experiment. Now, I might be able to speed this up so that you don't have to watch me continuously make this. So we'll see which one I got to do. So the first thing we're going to look at is our neutrons, which are balloons. Electrons are going to be the ping pong balls. And the stuff that connects them to my ceiling fan is going to be dental floss. Now, I'm going to go ahead, and I'm probably going to stop talking, and I'm just going to go ahead and do the experiment. The reason why I'm going to stop talking to do it is so that I can fast forward it later, and you guys won't miss any massively important information. Now, in my own defense, This stuff is brand new. Now, if you have something else at your house that you need things that are small, right? So we have things that are small, and we have things that are bigger. Now, I can't guarantee you that we're gonna get all the way to beryllium, but you'll get the gist by the time we get through this. So the first thing we're gonna do is separate these out based on color. The reason why we're doing a separation based on color is because of the problem with mass. So we'll probably get through hydrogen and helium today because we only have a small package of those. All right, so let's see color-wise. So I got 3 yellow and then 2 of the purple. So yeah, 2 and 2, got it. 1 and 1, got it. This little pink one is out of luck. So we're gonna throw that on the floor and hope for the best. So let's go ahead. We're gonna build ourselves first hydrogen. And hopefully reach did not make this difficult for me to get into it. Let's see. No, they did. It's so hard. Ah ha ha! Success! Success, success! On the floor. And if you've been in my classroom, you know that that's not an unusual place for it to be. Okay, so I'm going to use tape only because I don't want to have to waste dental floss tying this to the thing. So let me grab some tape, considering I just thought of it, and then we'll get going.